My name is Patrick Sung. I'm a professor of biochemistry and structural biology at University of Texas Health Science Center in San Antonio. Oh, I was born and raised in Hong Kong. I wasn't a very good student at all. In fact, I was pretty lousy. So what you would call a C student, never actually failed, but never really excel either, because my interests lie in some other things like soccer, partying, and so on. And then when I went to college at the University of Liverpool in the UK, in the United Kingdom, I realized that I better start working hard to build something, okay, to have a career and so on. And it was at the University of Liverpool when I worked on the senior project, I became totally sucked in the research part. I actually felt that this is something I could do for the rest of my life and just started my research career. And then I went to University of Oxford to pursue my graduate studies there. Came over to the United States, did a long postdoctoral training at the University of Rochester, got my first faculty job at the University of Texas, went to Yale University for 16 years, and I was recruited back to University of Texas about 6 years ago. Okay, so there are a lot of really outstanding geneticists and clinical scientists in this field. I don't pretend that I could even make any type of contribution in that particular regard. But what we're good at and where we can really make contribution is to utilize our biochemical expertise. We are really good biochemists. What we can do is to take the gene, tailor it in such a fashion so that we can have the protein expressed in a different system, typically insect cells and also in yeast cells. And then we develop procedures for their purification. And then we have to, in a very meticulous manner, to reconstitute the DNA repair reaction. That's dependent on BRCA1 and BRCA2. This is where we have been making contributions in the past 10 years or so.
And why is that meaningful to you?
Oh, it's extremely meaningful because unless you understand the mechanism, the genetics is fantastic. Without the genetics, you would never even know which gene to be looking at. And once you have the genetics, you ought to be able to reconstitute very complex reaction based on the genetic implications and so on. This way, you can identify the targets for drug development or explain why certain cancer-associated mutations affect protein functions. This is where we have been making contributions. We'd like to take the work to a different level to drive drug discovery and drug development based on what we learned in the test tube. Oh, that was a big surprise. You know, about maybe 8 or 9 months ago, our cancer center director alerted me to the opportunity. It was an internal competition. I had to compete with my colleagues, institutionally. And then they would select, okay, one nominee. The dean would do the nomination. I told the dean at the time, even though I was selected, this is going to be a really long shot. Why would, someone pick me over others who have also made, incredible contributions in the field. But then he told me, my dean, his name is Dr. Horomus, he told me, it's like applying for grant applications. One sure way to get a grant is not to apply. So let's go for it, even though it's just a long shot. But the long shot turned out to be reality. I just cannot believe it. Okay, so there are compounds, there are new drugs that are quite effective in treating BRCA-deficient cancer, including breast cancer and ovarian cancer. There's a class of drugs called PARP inhibitors. They work pretty well. Most patients will initially respond to them. But the major problem associated with these drugs is that after a short while, maybe after 2 years or so, the patient who initially responsive to these drugs, they become resistant. And if you look at the resistant mechanisms, there are multiple resistant mechanisms. We really need to tease out the biology that underpin this resistant mechanism so that we can find another new class of drugs to combine them with PARP inhibitors. That's where we're striving to achieve moving forward. There are few centers around the world, in fact, with the type of impact the Basel Cancer Center has been able to exert on the field. It provides the leadership by selecting an annual winner of the global prize. It just raises, the status Abraka research to a completely different level. I expect the Basel centers to still be leading the field moving forward in terms of recognizing the accomplishments of different investigators and also just driving the agenda moving forward. Also, it's crucially important for some high-profile center like the Basel Center to be talking to the civic leaders, to political leaders, and so on, that funding for cancer research is so important. Let's not, neglect the basic, science, We should keep on funding the work. There's certainly light at the end of the tunnel. Coming up with new drugs, new treatments, and so on takes a long time. But if we don't develop the foresight and know that we're in for the long haul, the prospect for futures, for patients in the future would be much dimmer. So we have to believe in what the basic researchers are doing. We're doing the best that we can. With adequate amount of funding and support, we should be able to tackle BRCA deficient cancer very effectively within maybe the next 10 to 15 years or so. So this would be our goal. This would be our aspirations. It's so great to be able to train graduate students and postdoctoral fellows to carry on what we do and to expand the scope of what we do because they have their own ideas, they're creative people, and I have great faith in them. So over my lifetime of being a researcher, I've trained about 40 trainees. Many of them are faculty now. Some of them are even my competitors. But we're able to compete on a friendly basis. We communicate results and so on, try not to overlap in what we do. It's just wonderful in that regard.